Little bit more about what it would be like to show whether or not this new teaching technique is effective. Remember, we've got two kindergarten teachers who have this new technique for teaching kids to be able to recognize and name the letters of the alphabet. We've had them do a before and after test with their teaching technique in the middle. So maybe at the beginning of the school year, they do this test on letter naming, and then at the end of the year, they do the same kind of test again. And throughout the school year, they give the kids the treatment, the teaching technique, or the independent variable. So we have this test, or the dependent variable, happening before and after so that we can see what growth is like. But because we need to check whether or not that growth is typical, we have to have a control group that's doing the usual stuff. So we do the same kind of before and after test, beginning of school year, end of school year, but this control group gets none of the new technique. And we do a lot of things to make sure that the teachers that are teaching in the control group do what was normally done before and not anything like what these two new teachers have developed. It's because we want to know if this is more effective than what other people have been doing. So these are key elements of scientific method. So when we figure out what the growth is for the treatment group, this new thing that the teachers have developed, we get that by checking the number of letters that they can name at the end of the year compared to at the beginning of the year, and that's our growth. Then we look at the control group for the same thing at the end of the year test. How many letters did they get right compared to how many letters they got right way back at the beginning of the school year? So I'm just going to dig in a little bit more deeply on what that would look like. So letters of the alphabet, there are 56 of them, 52 of them, 26 times 2 for the uppercase and lowercase. But I don't need to test every single one of these letters because you can see the ones that I have put a box around. The uppercase looks exactly the same as the lowercase in most fonts, or really close to it. So, and then the ones that I've circled with a circle are ones where they're close enough that I think that kids could figure out that's an F, that's a K, that's an M, even though they don't look exactly right. And that leaves me with these letters like Q and R and N and H, where the uppercase and the lowercase letter looks differently. I'm going to make sure that both of those get into the test. But that just gives me a little bit of efficiency. Instead of putting 52 letters on the test, I can cut out 14 of these ones that I've circled and boxed around, leaving me with only about 38 unique graphemes or letters that I need to put on the test. And the test is going to look something like this because we want to randomize the letters because we don't want kids to just be naming the letters based on their understanding of alphabetical order or their memorizing of the alphabet song. That's not what we're testing. We're testing the kids' ability to look at that letter and be able to say N right when they see it. Look at this letter and be able to say B right when they see it. So the instructions for this would be start right here and read across the page, reading one letter at a time, and tell me what is the name of each of the letters. Starting here, going here, then going across here, and as soon as you're ready, you can start. And I would do that exactly the same for every single one of the students. If I do it differently for any of the students, then it's the difference in how I gave them the instructions that's probably creating the outcome. So I have to do this in a standardized way. So this is one of the reasons why we have a lot of tests in school right now, is that letter naming has been shown to be an important predictor of later success in reading and writing. So we want to make sure that by the end of kindergarten, by the beginning of first grade, that most kids have learned almost all of these letters. So going back to our chart here, so that's how I got to those 38 letters on that test. So that is the test that I would give before. Then I would jumble these letters around again in a different order at the end of the school year to make sure that it wasn't just sort of a memorization effect. Probably wouldn't be by the end of the school year, but I'm going to jumble them up again for the end of the school year, but still have the same set of 38 in there for them to look at. So both the treatment group and the control group are going to get that same test at the beginning and end of the school year. So if I did that for a class of 25 students, this might be what my results look like. So I have 25 kids here, and I have two classes. I have the orange class and the blue class. So my results are that I had a 21 for this group and a 33 for this group. So I'm just going to come out to my actual chart here, sorry, my data here, and just show you what this looks like. So 21 to 33, sorry, I think I explained that wrong. 21 to 33 is pre-test to post-test for this class. So you don't need to be looking at all of these things here. The math that I'm doing in the middle here is some statistics stuff. I may talk about some of it, but let's just focus on the pre-test. So this is like August and September. I gave all of these kindergartners that kind of test. This is how many letters each of them got correct as they went through that test. The end of the school year, I gave the same kind of test, and this is what each of them got. So the pink column over here just shows how many letters of growth happened over the course of the school year, and the average of that is down at the bottom. So at the beginning of the school year, the average number of letters was just under 18. End of the school year, the average number of letters named was just under 30, and the subtraction from 23 to 1, from 32 to 28, this is just that simple subtraction. So the difference between 21 and 33 is 12. The difference between 7 and 31 is 24. So this is the growth. The average amount of growth was 12 letters over the course of the school year. So that seems great. So I've worked with kids that have an extreme amount of variety at the beginning of the school year, and I've helped, on average, each kid get 12 letters by the end of the school year. You can see that average isn't perfectly true for everybody. Some people grew a little bit, some people grew a lot, some people grew right close to that average of 12, but not everybody was right at that average. So I have to think about what that average means in terms of the control group. So if I did the same thing for the control group, where at the beginning of the school year I gave them the test and their average was just about 19 letters correct, at the end of the school year, the same test, same type of test again, their average is about 30 letters, and their difference is about 11.3, so a little bit less than the 12.04 that was over here. If I'm trying to prove that this is a superior method for teaching letter naming, and I'm getting not quite one alphabet letter more out of my kids on average per year, that's not super heartening for me when I'm doing a scientific study. So I don't have great evidence here that this is a superior method. So I'm just going to look back here at the growth again. So if I'm charting this kind of growth, I might also look at that same data by putting it onto a line graph so that I can see what this looks like. And the graphs look pretty similar to each other. And this is another way of looking at the growth. So if I put the average right here, and then I check the distance from the average for each one of the kids, my 25 kids along here, and I'm just going to show you what that is. That's this little number right here, the distance from the average. So either I'm below the average by a little bit, or above the average by a little bit, or a lot. I did that for the control group and for the treatment group to see how close they are to the average. And this shows that these two lines don't look that different compared to each other. This space between these kids, is it significant or not? I don't know. What I've done here with these two arrows is I'm pointing to the average distance from the mean. So when I add up all of these distances from the mean from this center line, and I see what the average distance is from the mean from here to here, There's 10 away from the mean. Here's one that's more like 5 away from the mean right here. Then I've got a kid up here that is, let's see, about 5 above the average, 10 above the average up here, and so on. When I average all of that out, what I find is that it's pretty normal for kids to be about 8 points away from the average. So most of my kids are there. I have about, let's see if I get over to the 8, I point right here. I've got about 4 kids over here, maybe 5 kids who are more than the usual distance away from the average. And the same thing up here at the top. I've got maybe 4 or 5 kids who are above average, more than the normal distance from the actual center point. That is what we usually talk about when we talk about standard deviations or standard error, which is that we take the average growth and then we check how does an individual, this one kid, deviate or move away from the average. Because this is a real kid that scored this score. There aren't very many kids that actually scored right on the average. So we want to talk about, what do these numbers mean for the individual kids. So when we take the average from here up, it's about average for kids to deviate from that mean by about 8 points. Everybody in this area is pretty normal. And everybody in this area over here is pretty normal. It's these 3 or 4 kids over here that are a little bit lower than the average distance from the mean, and the kids that are up here a little bit above the average distance from the mean. So that's about 8 of my 25 kids that are not in that sort of normal area. So that is what we're usually talking about. And I'm just going to bring this up. When we talk about a normal curve, and I'm just going to put up an image of that. This normal curve that you see right here, just bring that up. This is the average of the growth that we might see. And this first standard deviation from my chart would be those 8 points where it's normal for quite a few kids to be 8 points lower. That's the first standard deviation below the mean, that -1. The positive one here is the first standard deviation above the mean. It was really normal in my chart for a lot of kids to be about 8 points above the mean. So this meaty part right here of the curve is usually describing what is normal. As soon as you get to this second standard deviation out here, that's less than normal. In my chart, it didn't look, really long and wide like this. It was much more stuff right underneath here, and then it just dropped off really quickly down to those 3 or 4 kids. And over here, the last 3 or 4 kids dropped right down really quickly. So, and that's because we're just talking about a limited number of letters. A big, wide, normal curve like this is more appropriate when we're talking about something open-ended like comprehension or vocabulary, where kids can learn an infinite number of words, or they can understand more and more things as they grow older. But there are only 52 letters, so the curves are going to be a little bit stranger. Okay, I'm going to go ahead and stop there.